Okay guys, so here is 8.2. What we're going to be doing today is talking about the law of sines and law of cosines. Last class we talked specifically about right triangle trig, and now today the difference is we're still talking about trig, we're still talking about solving for the parts of a triangle, but the difference is that these are not going to be right triangles. They are what we call oblique triangles. They are not right triangles. They could be acute, they could be obtuse, but they are not right. And there are two ways that we're going to learn to solve these triangles. The first way is called the law of sines, but here's the case scenario. So you look at the triangle and you say, what is the given information? If you have the following information given, so let's just draw any old triangle here. Let's say we have a side, we know an angle, and we know another angle. So that would be side, angle, angle. I don't know if you remember that from geometry, or you could say angle, angle, side. That's the information that you could use the law of sines. The second case scenario that you could use the law of sines would be if you look at the given information and you have two angles and a side. Those are my angle markings. So this one would be angle, angle, side. No, it would not. It would be angle, side, angle, angle, side, angle. I just did angle, angle, side. And then the third case scenario would be a side right next to it and an angle. And that one would be called, oh, I almost said angle, side, side. No, 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 no. I can't say that. That's against the law. I can say side, side, angle, though. So those are the three case scenarios. Now, let me show you what I'm talking about before I give you the formula. If we come down here, before we do this example, what are we given? Notice that we have an angle, a side, and an angle. So this would be ASA. Yes, we could use the law of sines, and that's what I'm talking about when I say the given information. So let me tell you the law of sines. The law of sines is actually pretty simple. All it is you're going to take the sine of an angle and you divide it by its opposite side, and you equal it to the sine of another of the angles from the same triangle. You divide that by its opposite side, and now notice that we have three sides to choose from. So the law of sines is any combination of two of these. You could have the sine of A over A, sine of C over C. Sine of A over A, sine of B over B, B over C. You know, those kind of, or sine of B over B, C over C. So it's going to be a set of two of these, any of them, and then you just simply cross multiply and solve. It's really quite simple. Remember, the little A, B, and C are opposite the big angle A, the big angle B, the big angle C. Now, I'm using ABC as an example just because we have ABC here, but it doesn't have to be ABC. It could be EFG, it could be JKI, it could be any triangle that you're dealing with. So let's look at the very first example that I have, and it says solve the triangle. So once again, we know that there are 6 parts of the triangle. So let's do what we did yesterday, or the last lesson, and let's list all 6 pieces of information. So I'll start with my angles. So there's angle G, there's angle F and angle E, and some of this we can fill in. And then we take a look at the sides. There's little g, right? Because remember, big G's here, so this would have to be little g. There's little e, little f. And we're going to fill in what we know, right? So we know little g, make that look more like a G, 14. We know little, angle E is 45. And we know angle F is 62. Okay, so why don't we start with finding angle G? And the reason why I say we can do that is because I know, actually, no, I don't want to solve for, actually I can solve for angle G, but do I have to use trig to do that? If we think back to what we did last class, remember the 3 angles of a triangle have to add to 180. So we actually don't have to use trig to solve for G, and we will need this angle in order to use the law of sines. You have to know one angle on its opposite side. So let's start by finding angle G. And to do that, we're going to add angle E and F together. So that's going to be 45 plus 62. We're going to take the sum of those two angles and we're going to subtract that from 180, and that will give me what angle G is. So we'll go ahead and just punch it in here real quick. So and you can do it along with me. And I got 73 degrees. And there's angle G. Okay. Okay, so now I'm going to come up here and I'm going to write that inside the triangle. Now I'm going to choose one of the other letters to solve for. How about E? Okay, so to solve for E, which will be the second thing I do, let's solve for little e. If I'm going to solve for little e, then obviously I need to have little e in my formula, which means I have to have big E in my formula. Remember, it's the sine of an angle divided by its opposite side. So if I'm looking for E, then I have to use big E. So the formula I'm going to use is sine big E over little e. Now, remember, I got to set up another ratio, so you're going to use what you know. I know G and little g. You have to use that. You cannot use F because we don't know what side F is. You have to be able to put in 3 numbers out of the 4. So I have to use the sine of G over little g. And now I'm just going to put the numbers in. The sine of E is 45. Divided by little e, which I don't know, is equal to the sine of G, 73. Remember, it's going to be the sine of 73 over little g, which is 14. So I'm going to cross multiply. So I'm going to multiply these two together. Well, that's easy. Sine of 73 times E equals 14 times the sine of 45. Now I want to solve for E, so I'm going to divide both sides by sine of 73 to remove it from this side. And this right here is what you're going to put into the calculator. So we're actually going to calculate this whole thing. Okay, so let me try it out here. Let me get my calculator going here. Turn it on its side. Okay. So let me see if I can do it on this. I didn't even think to grab a calculator before we left school. So I'm going to get the entire numerator first. And the way I'm going to do is I'm going to go the 45 sine, get that number and times it by 14. That's how I'm going to punch it in. So I'm going to say 45 sine. Oh, shoot. I'm on inverse. There we go. We don't want inverse because we know the angle. So I'm going to hit sine. There's the sine of 45, and I'm going to times that by 14. And that's going to be my numerator. Now I'm going to take that number and divide it by the sine of 73. So I'm going to hit divide parenthesis 73 sine, close parenthesis, hit equals, and I get about 10.35. And there's E. Okay, 10.35. All right, so now I can come over here and write E. Unfortunately for F, like last time, we were able to do something besides trig, like we could use the Pythagorean theorem, but remember, this is not a right triangle. We cannot do that. You are going to have to do the same thing. Really, it's going to be the exact same thing, except instead of a sine of E, you're going to have a sine of F. So when you go through the formula, everywhere you see a sine of 45, you're actually going to now have a sine of 62. So right here in this bottom formula, it's going to be 14 times the sine of 62 divided by the sine. It's going to be the exact same thing. I'll go ahead and set it up for you though. To solve for to solve for F, you're going to say the sine of big F over little f is the sine of g over little g. The sine of 62 over f equals the sine of 73 over 14, cross multiply, and we get the sine of 73 times f equals 14 times the sine of 62. So we want to divide by, you see how it's exactly the same thing that we just did. And there's f. So you see how it's exactly the same thing except there's a 62. So you're going to punch it in the same way except you're going to do a sine of 62. And that'll give you f and we're done. Now this is a long problem. Most of these are only solving for one thing, which I'll show you one more example here how it's a lot quicker most of the time. But let's go ahead and punch that in. So once again, I'm going to start by finding the sine of 62. Sine. And I'm going to times that by 14. And there's my numerator. Now I'm going to divide it by the sine of 73. So when you hit divide, you have to hit your parenthesis, at least I do. And you're going to hit 73. And what is the sine of that? But that's not the answer. You got to close your parentheses. That's what your denominator is. And then you're going to hit equals. And we're going to get 12.3 maybe. I'd say about 12.3. I mean, not 12.3. 12.93. It says we're now to the nearest tenth, so that would be just 13 then, 13.0. What was this one? This one was 10.4 if we rounded the nearest tenth. I didn't read the directions. Okay, so not 12.92. Actually, the 2 is not going to round the 9, so I'm just going to leave it as 12.9. And there you have it. Okay. Okay, I have just one more example of the law of sines. Most of the time you're only going to be solving for one thing. Like here, I just want to know angle t. I mean, not the angle t, that's a side t, little t. So that's going to be little t right here. So remember, in order to do that, you have to use t in your formula, which we do know. Angle t is 69, and then you have angle r and side r, so there's your formula. So we're going to say the sine of r over r equals the sine of t over t. You have to be able to fill in all three parts, which we can. The sine of 39 over 12 is equal to the sine of 69 over t. You're going to cross, multiply, and solve. So multiply here. So I would get t times the sine of 39 equals 12 times the sine of 69. We're going to divide both sides by the sine of 39. And there you go. And that's what we're going to be solving for. Now, is it possible that you're going to have to use inverse to figure out one of the angle measures eventually? Yes. Yes. So, like for instance, we happen to know the angles and we're looking for a side, but it is possible that you might have to look for an angle as well, but it's the same thing. You just cross multiply, and if you're looking for an angle, you just have to end up taking the inverse at the end. All right, so let's punch this in. Okay, so once again, same thing. I'm going to get my numerator completely here. So 69, the sine of that, times 12. My numerator divided by parentheses 39 sine. Close parenthesis, and there's my answer, about 17.8. There you go. All right, so law of sines is if you have side, angle, side, angle, 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 side, side, angle. Now, every triangle is not going to have those, though. So there's one more theorem. Actually, it's a law. It could also be considered a theorem as well, called the law of cosines. And so you're going to use the law of cosines if you have the following information. So let's say you have a triangle and all you have are the three sides. You know this side, you know this side, you know this side. So that would be side, side, side. And the other case scenario for the law of cosines would be you know a side, you know an angle, and then you know another side on the opposite side there, or the adjacent sides with an angle between. So that was called side, angle, side. So those are the two case scenarios. Now, this formula is not quite as simple as the law of sines. However, I think after I get the first one down for you, you're going to see a pattern and you'll be able to figure it out. So here's how it works. So you pick a side that you want to start with, and I'll just start with A. So if I wanted to find A, the formula is A squared equals, you're going to add the square of the other two sides, B squared plus C squared, and then you're going to minus 2 is a constant, the product of those two sides, B and C, times the cosine of angle A. So this will match this. So if it's little a here, you'll have big A here. And that's called the law of cosines. So if I wanted to find B, now I'm going to use B squared, and then I'm going to use A and C inside the formula and B at the end. If I wanted to find C, then I'm going to use A and B inside the formula, and I'm going to use C at the end. So as you can see, it's a formula. So I'll write all three of them for you. So B squared equals A squared plus C squared minus 2AC times the cosine of B, and then the last one would be little c equals B squared plus A squared plus B squared, doesn't matter the order, 2AB cosine of C. Now I used ABC, but it could be EFG, it could be JKI. So like if it was EBC, that's not a good example. Let's just say EFG. So it would be E squared equals F squared plus G squared. You know, it's the same. Just know that it's the other two sides in here, and then the angle measure opposite, whatever is this one, is going to match. Okay. All right. So I think I have two examples of that. Solve the triangle. So once again, we have to find all three sides, all three angles. And like I said, I'm just going to do one of these. The other ones usually just ask you for one piece of information. So it's not like a zillion, you know, length, how many ever minutes it takes to do the whole one. So, but this will show you everything. So, and you know what I'm going to do, just because I use A, B, and C all the time, and I want to do something different. I am going to use, instead of A, B, and C, I want to change it to EFG, just to give you some exposure to different letters besides A, B, and C. So the three angles I want to find are E, F, and G. And I already know the three sides. So I already know little e, little f, little g. So if I find these three angles, then that'll be everything that I need. So I'm going to start with E. So remember, if you're going to find angle E, you want to use the formula that would have an E in it. And if you recall from the formula that I just gave you, that whatever angle you want to find, you start with that opposite side. So I would start with, this is going to be little e, this is going to be little f, this is going to be little g. All right, so it's going to be E squared equals F squared plus G squared minus 2FG times the cosine of E. So that would be my formula. Filling that in, I would get 25 squared equals 35 squared plus 20 squared minus 2 times 35 times 20 times the cosine of E. Now we're looking for an angle measure, so when we go to calculate this, we are going to use inverse. All right, so 25 squared is 625. I happen to know that. Now let's go ahead and figure this out. I'm going to figure this out in three parts. We're going to figure out what this number is and what this number is. Don't worry about the minus because we're going to take this minus this. Okay, so let's do that. Well, we're not going to take those two numbers, but we'll just keep the minus as a minus and not as a negative 2, if that makes any sense. All right, so let's calculate that. So we're going to say 35 squared plus 20 squared. And I get, oops, did I hit something? Let me go back. 35 squared plus 20 squared. Oh, I didn't hit it. I didn't hit enter. Equals 1625. I didn't hit equals. Now we're going to hit 2 times 35 times 20. And I get 1400 times the cosine of E. Okay, now notice that the 1400 is attached to the cosine. That's multiplication. So you do not want to do anything with that. What you're going to do is subtract 1625 from both sides. That'll cancel here. And we're left with negative 1000 is equal to negative 1400 times the cosine of E. So now we're going to divide both sides by 1400. Oh, and it's a negative 1400. And we get the cosine of E equals 1000 divided by 1400, which is 0.714, right? You can just do 3 places, 0.714. Now we're going to take the cosine inverse of that. You could actually do the cosine inverse of that if you wanted, but I'm going to do the cosine inverse of 0.714. So I have to hit, I have to hit second, and I've got that number there. I'm going to hit cosine inverse of that. And I get about 44 degrees. I'm going to round it to the nearest whole degree, 44 degrees. Okay. Now, here's the beautiful thing. Once you have one of the angle measures, when you have a side-side-side situation, once you have one of the angle measures, you can now go to the law of sines. If you think the law of sines is easier than this, then go back to the sines. You just need to get one angle using the cosines. So as an example, if I want to find angle F, I can now use the law of law of sines using E over little e. Right? I could say sine of 44 over 25 equals sine of F over 35. Cross, multiply, and solve. So let's do that. To me, that's way easier. So this one, we were solving for angle E. That was the first thing we did. Now I want to solve for angle F. Okay, and I'm going to use the law of sines. The sine of F, which I don't know, over little f is equal to the sine of, we have to use the one we know, E little e. 25. Cross multiply. Now this is one where we're going to be figuring out the angle measure. So you're still going to cross multiply. So we're going to say the sine of f times 25 is equal to the sine of 44 times 35. God, this lesson is so long. Hopefully you're pausing and taking a break. Oh yeah, I had to pause and take a break. Had to do some brain yoga. Okay, so we're going to divide, and we get the sine of f equals. Now, remember, you're going to calculate that. You're looking for an angle measure. You're going to take the sine inverse of the decimal you get for that. So let's go ahead and calculate that out here. So once again, I'm going to start with the sine of 44. Oops, shoot, I'm on inverse again. So you just want to be on the regular sine. Times 35. There's my numerator. I'm going to divide that by 25. There's my decimal. Now I'm going to take, remember that's going to be this whole thing here. I'm going to take the sine inverse. I'll round it to the decimal, but you can just leave it on the calculator and go right into sine inverse. So I'm going to hit second, sine inverse, 77. If I rounded it to the nearest whole degree, there we go. Okay, so now once I have the two angles, you do not need to use trig. We know that the three angles add to 180. So, sorry, I'll do it up here, I guess. So the third thing is to solve for g. We're going to take 180 minus the sum of 44 and 77. And that will give me 59 degrees. There you go. And there's your answer. Okay. All right, last example using the law of cosines. We just want to find one thing, and that's going to be side A. Up here we had side, side, side. Here's an example of side, angle, side, and we want to find side A. So we're going to use the formula that has side A in it. So we're going to say a squared equals b squared plus c squared minus 2bc times the cosine of A. And this would probably be one where I would say, okay, I want you to set it up for me. So if you wanted to hit pause and maybe try it on your own and then come back and see how you did, that might be a good idea. That's probably what I would have done if we were in class. But anyway, I'll finish it up here. So B is 23. C is 25. Minus 2 times 23 times 25 times the cosine of 51. So that's how you should have had it set up. Now, we're just going to calculate that. Once again, I'm going to calculate this in different parts. So I'm going to get this, subtract. You could actually probably get that all one number, and you're going to take this minus this. Now notice that's going to give you a squared, so you're going to end up having to take the square root of that. So let's give it a shot here. All right, so clear, clear, clear. My emails will not stop. Okay, so here we go. 23 squared plus 25 squared equals, okay, so that I'm going to put 1154 minus, now I'm going to get one big number for that. I'm going to go ahead and hit clear. 2 times 23 times 25. I'm going to go ahead and get an answer for that. And then now I'm going to times that. I'm going to go ahead and times it now, but you have to hit parentheses 51 cosine. Oh, don't be on inverse. Regular cosine. Now hit close parenthesis and hit enter. That's going to be actually this whole thing, because I went ahead and included that. So this whole thing is 752. So what I did was I went 2 times 23 times 25, and then I did parenthesis 51 cosine. Enter. Jeez, sorry about that. I went to almost sneeze. Sorry about that, guys. Wake up! Wake up, everyone. Sorry about that. So I went to hit, I just punched the whole thing in, and that's what I got. So if you want to go back and watch what I did. So anyway, now I'm going to subtract these two and take the square root. All right. Okay, here we go. 1154 minus 752 is 402. So a squared equals 402. We're going to take the square root of that, which is right here, and I get about 20.04, and they want us to round it to the nearest tenth. Well, that would just be 24, or just 20.0. So A is approximately 20. Okay, there you go. All right. Okay, you'll be happy to know we're on the very, very last thing. And that is, how do you find the area of a triangle that you don't know the base and height for? Because normally the area of a triangle is 1/2 base times height. Well, how is that going to work if you don't know what the height of the triangle is? Remember, the height is from a vertex straight down. Well, there's two formulas you can use depending on your given information. And this one, if you know side, 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 you're going to use Heron's formula. Heron's formula is used to find the area of a triangle given all three sides. If you remember that from geometry, side, 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 angle, side. So for instance, this is all three sides. So let me give you the formula and then we'll look at an example. And then I have one more area formula, and then I think I have, let's just do one more example, I guess. I don't know, I guess we can do both. But anyway, here we go. Okay, so we want to find the area of the triangle. First of all, let me give you the formula. So here's Heron's formula. To find the area, you take the square root of what we call S, and I'll explain what that is here. But it's, and then you take S minus A, that's an S, times S minus B times S minus C. Now let me tell you what S is. S is called the semi-perimeter. And what the semi-perimeter is taking all three sides and adding them together. So like perimeter is distance around, right? This is S. But then you take that number and divide it by 2. That's what your S is. So first you would find your semi-perimeter, and then you would go back in, plug it in, minus the first side, minus the second side, minus the third side, multiply all those numbers together, take the square root, and that's your area. So as an example, we want to find the area. You notice we know all three sides. So the first thing you want to do is find your S. And you're going to say 22 plus 40 plus 50. And you're going to divide that by 2. So 90, 100, and 2 divided by 2 is 56. Or is that 112? It's 112, so it's 56, yeah. Because you're going to do 90. Yeah, it's 112 divided by 2. Okay, so there's your S. So once you have your S, now you're going to take the square root of the S, that's the first number there, and then you're going to say 56 minus your first side, 56 minus your second side, and order doesn't really make a difference, by the way, and 56 minus your third side. Okay? Now, you could punch it in just like that in the calculator, depending on what kind of calculator you want. It may be easier to go ahead and get the 4 numbers. So, for instance, 56 minus 22 is 34. 56 minus 40 is 16. 56 minus 50 is 6. So it might be just multiply those 4 numbers and take the square root. I mean, like I said, depending on your calculator, but I'm just going to go ahead and do this one. So, okay, so 56 times 34 times 16 times 6. I think I hit something. Is that right? Well, let me try it one more time, just double check. 56 times 34 equals. Now I'm going to times that by 16 equals. And now I'm going to, yeah, I was right, times that by 6. Now, I don't know if that was what I just got a minute ago or not, who knows, but anyway, I think that's right. Anyway, and now you're just going to take the square root of that number, which there's your square root button right there, and we get about 427.5. And it doesn't say if it's inches, feet, whatever. It's So we'll just say units squared. Okay, there you go. All right, one last formula. What if you want to find the area of a triangle and you're given side, angle, side? So I guess I'll just use ABC here. Side, angle, side would maybe you might know side C, you might know side A, and you're given angle B. You might know these two sides given angle A, these two sides given C. You know, it just depends on what you know. But what you do is very simple formula. I call it the SAS formula. To find the area, you simply take half of the product of the two sides you do know times the sine of the angle you know. And that's it. So it just depends on what two sides and angles you know. So if I knew B and A, then I would do half of A times B times the sine of A. You know, so it just depends on which two you know. All right, so let me give you a quick example of that. So here, you're just going to take the two sides you know, so side, angle, side. So area is going to equal 1/2 of 3 times 15. 5, excuse me, which is 15, and then you're going to take the sine of 55. And you just multiply that out. And that's all you got to do. 0.5 times 15, I already know, is 3. And times 5 is 15, is 7.5 now, times the sine of 55. It's 55 sine. And I get about 6.14. And that would be in terms of inches squared. So area is always squaring the units. Last but not least, I don't know about you, but I'm glad this is the last one. I am tired. You are seating a triangular courtyard. The three sides of the courtyard are 46, 51, and 52. The angle opposite the 52-foot side is 65. One bag of grass seed covers an area of 50 square feet. How many bags of grass seed will you need to cover the courtyard? So whenever I do a word problem, I always like to draw a diagram. So one side is 46, another side is 51, another side is 52. And then we're told the angle opposite the 52 is 65. One bag of grass seed covers an area of 50 square feet. How many bags would I need to cover this entire area? Well, what I would do is decide, first of all, how am I going to find the area? Well, you know side, 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 so if you like Heron's formula, you could use Heron's formula. I don't know about you, but I think a lot of the SAS formula is the way easier. You just take whatever angle, you take the sides on either side of that. Those are your two sides, so it's side, angle, side. Product of those two times the sine of that, half of it. Boom, you've got your area. So personally, SAS formula is going to be the easiest way to find the area. So it's going to be 1/2 of 46 times 51 times the sine of 65. That's going to be my area. Okay, so now we're going to punch that in. Let me get my calculator going here. All right, so let's punch that in. So I'm going to take, I'm probably just going to work this way. The sine of 65. And then I'm going to times that by 51. 46, 51 times 46. And then I'm going to go ahead and divide that number by 2. And I get 1063.09. So we'll just say about 163. How many bags of grass seed will you need? That's actually what the question is. So the area, we'll say, is 1063 approximately. And of course, that's going to be in terms of feet squared. Well, the question is not asking how much grass is there altogether. They want to know how many bags of grass seed will you need to cover. Now, notice that they say that one bag covers 50 square feet. So how will I figure out how many bags I need? Is you're going to divide that by 50. And that's going to tell you how many bags. So I'm going to take this number and I'm going to divide by 50. And I get 21.26. Now here's the question on rounding. Remember, the 0.26 part is part of the grass. That's part of the area that you're going to need to cover. So yes, you need 21 full bags, but if you don't get the 22nd bag, you're going to skip this 0.25 here. So you're actually going to need 22 bags. You always want to round up when it comes to things like this. So how many bags of grass seed will you need to cover the courtyard? 22 bags. And that is the answer. And that is the notes on 8.2, guys.